All right, so I'm going to go over some different options to model pickup and drop-off operations in Vissim. So first off, I'm just going to talk about some of the different pickup drop-off operations and what we kind of the behavior that we want to model, and then look at implementing that in Vissim, and then also using some scripting to kind of further define both the vehicle and pedestrian behavior. All right, so here is a little test model here in good old Centerville, Virginia. So what vehicles will do, let me see if I can turn on this laser pointer here. Yeah, so vehicles will come into the network and then they will go to the drop-off area where passengers can alight. And then from there, they'll move down here to this bottom staging area where vehicles will wait to advance until this waiting area up here at the top has enough space for them. And then from the waiting area, the vehicles will advance into this pickup area, pick up the passengers that are queuing there, and then exit the network. So these are the 4 different areas that we're looking to model and get that behavior in Vissim. All right. So the network modeling. So the dream here is to use as many of the built-in features of Vissim as possible so that we can kind of minimize the amount of scripting that we need to do and add on. So here is the journey that we're going to go on. So the first part we're going to look at is creating the staging area and allowing vehicles to kind of wait in that separate area before advancing to the waiting area. So slight spoiler alert, this is going to use priority rules. And then from there, we're going to look at modeling passengers in the drop-off area and in the pickup area. And in this case, we're going to look at doing that with public transport, and that way we can utilize the integration with VisWalk. And then, as you'll see, we're going to further define that behavior using some scripting, and then using that to trigger different signal heads in the network to further define that behavior. All right, here is the roadway network. So again, we'll have the drop-off area over here. Vehicles will come and sit in the staging area down here. And then here they'll pull up into the waiting area and then advance into the pickup zone. And then over here on the left, just have a little VisWalk pedestrian areas built in so that people can enter the network, weave through this gigantic queue line here, and then pick up and enter the vehicles. All right, so the staging area. So essentially we want vehicles to come into the network and then stop at this particular location until there's enough room for them in the waiting area. So in this case, we ended up putting in 3 different stop bars for the priority rules so that we can really define this very exact path that we kind of want to block before the vehicles will advance. What will happen is if you put in just that single conflict marker, then that can also go kind of upstream and capture some of the vehicles that you don't want to include in there. So essentially, once the vehicles advance in the waiting area and are out of the conflict zone, then those vehicles will advance. So here is a video so you can see it in action. So once those vehicles start to advance from the pickup area and kind of clear those zones, you'll see the next set of vehicles advance from that staging area. So this works out pretty well. There is one thing that there's going to be that slight delay as the vehicles are actually advancing out of the waiting area. But other than that, this works really well for allowing vehicles to stop in one area of the network when you're looking at a separate area to kind of block off and have vehicles wait. Yeah?
So were the intermediary priority rule, the green bars, is that there so that it only released a certain amount of vehicles?
Yes, yeah, so kind of fine-tune those so that we could get 3 to advance. In the pickup area, we'll have 3 vehicles stopping, so yeah, just fine-tune those to get that.
So is that the reason why you don't put a stop sign?
Yes.
Would be the stop sign, right?
Yeah, so if you do a stop sign, then you can only really define like a dwell time there. So you can't really like block off a certain area since it's kind of further off in a different region of the network. All right, so next part of our journey, the drop-off zone. So in this case, the first thing we actually looked at was just using parking lots. But then we really did want to incorporate VisWalk into the model as well. So that's kind of when we turned and started to look at using public transport instead. So here we've just got a single PT stop, and this is long enough to allow 3 vehicles to park there and dwell at the same time. And then on that, we just created a VisWalk platform edge so that the passengers can alight there. And you'll see here's where you can kind of set up your settings so you can choose which side of the vehicles you want the passengers to alight from. And then you can also set the percentage of passengers getting off. So if you did have multiple drop-off zones, you can adjust that percentage to have passengers get off at different stops. And then one other option that I also turned on for the drop-off is to allow the skipping possible. And what this will do is if a vehicle has no occupants on it, then it will just bypass that stop and keep going on in its journey. All right, so here you'll see some of the vehicles pulling up here, dropping off their people. And then you'll also see if a vehicle, again, doesn't have any occupancy, then they will just bypass that stop altogether. And in Vissim, you can also define a time for each of the passengers. So as they're alighting, they each kind of have a time associated with them for the vehicles to dwell there. Okay, so moving on to boarding. First take here, so our first trial. Great thing about simulation is that you can try a bunch of different things if something doesn't work out. So in this case, kind of just started off doing the same thing as the alighting scenario. So in this case, having a single PT stop here that will allow 3 vehicles to park, and then having that platform edge for the pedestrians, and then also a waiting area for them as well. So I will play this video so you can see the passengers here. So you'll notice as the vehicles stop up here, people are very eager to get into the first vehicle, but not so much into any of the others. So a lot of them, they'll start, they're like, oh, I want to go, and then they're like, no, this is wrong ride. So they'll just kind of come back to the waiting area. So what we found out is that when you're modeling it with a single stop, they will just tend to go to the first vehicle that's arrived there. So not quite the behavior we're looking for. And you'll see here on the left-hand side, I have the occupancy displayed, so you can see again the first vehicle will just get all the people, and then everybody else is empty. And then passengers get left behind, so they're just kind of sad too. So
is this like public transportation?
yeah, this is using the public transportation stop and then line definition. Yep. They are, yes. So for these vehicles, since it is on a PT line, they do have like a scheduled entry point into the network.
Because this is very useful, would be very useful for ride sharing and modeling taxis, TNCs, and working in airports. So this is something that would be very useful for me. But the problem is that they are on a tight table.
Yes,
So
yeah, that
how
is.
do we get past that?
Yeah,
So that's the question for the developer.
yeah. Okay, so the second option we looked at doing is taking that single PT stop and splitting it up into 3. And then each of those stops have their own platform, edge, and waiting area. One of the interesting things here is that once you split up those waiting areas, then you have to define the pedestrian static routes to each of those areas so that people aren't necessarily served in a first-come, first-served basis, since they're all going to their waiting areas. So sometimes they won't necessarily get served in the correct order. Also with this option, right now this is modeling it still with a single PT line. So what can happen is sometimes the vehicles will stop at multiple stops. So I think sometimes a vehicle would here board a couple people, then they'll advance and then board a couple more people and then keep going. So great if you want to model shared rides, I guess, but not quite what we're going for here. I also did look at modeling this with 3 separate PT lines as well, but that can pose some issues if your vehicles get out of order. Like say, for example, your vehicles are dropping off people, but then you've got one that bypasses the drop-off zone. If they're out of order, then they'll get to the stops in the wrong order, which can lead to some gaps that arise. All right, so far, what worked really well is using the public transport for the alighting portion and being able to model multiple vehicles stopping there at the same time. And then using those priority rules to create that separate staging area behavior. Some things that I'd like to improve upon is to actually get the passengers to board, first come, first serve, and to get the vehicles to stop in the correct positions. And then also looking at trying to minimize that delay when the vehicles are leaving the waiting area before they're released from the staging area. So this leads us into the world of scripting. Okay, so here is what the network setup will look like. For the most part, we've added in kind of a signal head here so that we can stop and start the vehicles when we need to. And then we have an exit detector at some of these locations so that we can count the vehicles as they're leaving, so that we can really specifically control the behavior. So we can say, okay, we want 3 vehicles to advance from here. When we count the detector impulses, we can switch that signal off to red and then wait until we trigger that again. So for that staging area, again, we have that signal head and then the exit detector. And similarly for the waiting area, that also has a signal head and exit detector. And same thing for the pedestrian areas as well. So that has a really short little exit detector so we can count people as they're boarding the vehicles. And then the pickup area itself, to model this, we actually used stop signs to park the vehicles at each of the spot. And each of these stop signs will have a signal group associated with it, so we can still turn it on and off. And then we can also set a dwell time on those stop signs, which I'll talk about more on the next slide. And we can update that once the passengers have boarded. And each of these spots also have an exit detector, so we can capture the vehicles as they're leaving. And then there is a final larger detector so that we can, kind of in that last spot, so that we can know when that whole area is kind of fully occupied and we've got vehicles stopping there. All right, so here is kind of just the layout of how the logic works. So essentially vehicles will enter the area as they are progressing here and they pass the detector. It will trigger that downstream signal head so that we can get the vehicles to stop at each of these. So it'll turn that signal group red to allow the vehicles to park. And then as they're leaving from that waiting area, they'll get assigned a desired number of pedestrians that should be boarding that vehicle. And then once that vehicle has parked and we have this vehicle here on that last detector and it's considered occupied, then we'll set the dwell time on the stop signs to infinity just to get the vehicles to stay there. Otherwise, if it's, we'll update that dwell time later. And then we'll turn the pedestrian signal head green so that we can allow the pedestrians to actually board the vehicles. So as the pedestrians are boarding, they'll trigger that small exit detector there. And so we're using that to keep count and compare that to the number of desired pedestrians we want on each of the vehicles. So that signal will turn green if we want like 2 vehicles to board the first one. And then if you only want 1 on the second one, it will let the next one out, and so on. And then once those pedestrians have boarded each of those vehicles, we'll update that dwell time based on the number of people that are boarding so that we can still have kind of a time associated with each person. And then We also have another time associated with the spot location, since it'll take pedestrians longer to travel to that last spot than to just enter onto the vehicles on the front. So once that dwell time has finished, then the vehicles would kind of be in the exit mode, and the stop sign signal group will turn green to allow them to advance. And then once that final vehicle has passed this last detector and it's out of the pickup area, then we can turn on the signal heads for the waiting area and for the staging area to allow that next set of 3 vehicles to advance as well. Okay, so here's a video of that behavior. So you'll also see the vehicles in the pickup area have different states associated with them, so they'll change their color based on their state. Sorry for the slow pan in, but they'll turn green when they park originally and are waiting for people. Once all the people have boarded, they'll turn a darker blue, and then they'll turn yellow very briefly when they're ready to leave. And that signal head will turn green. And so here you can also see the pedestrians have that giant stop bar there too for their signal, and then they just have a really small detector in front of that to count them as they're getting let out. So by using the scripting logic and using the signal heads and detectors, we're able to get the people to board in the correct order, and we're able to get those 3 vehicles to pull up and park in the correct order as well. All right, so a few different options for modeling that pickup drop-off. Anybody have any other questions? Yes?
So in this one, you're assuming that all the people are going to the same destination? Or?
Yes, yeah, correct. Right now, once they get picked up, they're all just leaving the network. Yep.
So you're not matching people according to the destination in this person?
No, not in this one. Yep, they'll just, whatever vehicles pull up, they will all board. Yes, Levi.
But those routes, they're not public transit routes, right? They're just normal static routes again, so you could theoretically do this process with either static or dynamic assignment routes.
You could, yeah.
And then just reroute the car after you figure out which pedestrians are boarded on them, so.
Yeah, you could track it. Yes.
So, I guess first I thought you were not using parking zones because you wanted to visualize pedestrians going into the cars, but then I see
Yeah.
in the scripting you lose that, right? So
Yes.
You're not using the parking.
Yeah, not using the parking lots anymore. Because those also, you have to kind of set that dwell time in advance. So we still wanted to let the people, based on the queue that forms, to board. So like if you did have a gap in your queue, then you'd want those vehicles to sit and wait at that like parking area a little bit longer. So with the parking lots, you do have to just define like that dwell distribution. So this just allows you a little bit more flexibility with that.
Right. And when you say scripting, is that in lab or?
This was in Visual Basic. Yeah. Yes.
The vehicle types that were picking them up, those were bus or transit or?
Oh, they were still car.
They were?
Yep. Yeah. So you can just set any vehicle type on the public transport line that you want to use. And then I also set like a capacity on those as well. So it still uses type car, but has like a capacity of 4 or 5 people.
And so you're saying you didn't use parking lots because you're trying to avoid setting the goals and all that, but isn't that what you kind of ended with? Kind of ended with them still just using one spot?
Yeah, they're still using one spot. With this point, at least, they, because as they're walking through the queue, kind of that queuing area gets captured here, so that you can kind of see as the people are entering the network. If you did have like any gaps or anything like that, then your pickup vehicles would end up waiting until those people have made it to that area to board.
So is there any plan for PDB to include some of these features in Vissim without needing scripting?
Oh, that.
I think that's what you can say like tomorrow during high peak.
Yes, great idea.
Are you signing up now?
I know, I think that you have just volunteered yourself.
Volunteer,
Thank you.
Yeah, yeah, for hot seat. Yeah.
Do you think this would be a good candidate to include as an example file with Vissim?
Ah, that's an interesting question. I mean, yeah, maybe that's something we could do, yeah. I'll have to clean up my code a little bit. So, yeah.
It's challenging to model I think it's challenging to model pedestrians moving to different cars, you know.
Mhm. Yeah, it is, yeah. Yep, that's what we definitely found out with, yeah, some of their logic is difficult when they're trying to board, when you can allow boarding on multiple vehicles. Yeah.
Did you look at, not just sitting in a straight line one by one, or maybe if someone was stuck in that first spot, you could go up in front of them and pull in front of them?
No, not yet. But yes, definitely thought about doing that, is to allow kind of like vehicles to bypass and get out. Yeah.
Longer
Mhm.
curbside or something.
Yep, for sure, yeah. All right.
So to follow up on the example file, I think we are including that example in 2020, correct? With Sven's taxi stand example?
Yeah, I think there is one example. It's not this one.
It's not this one, but it's similar with the scripts, kind of doing the same thing at like an airport.
Yeah. Yeah, that example is very robust.
Yeah.
You can do a lot of stuff with it, for sure. All right.